Hi guys, we meet again. So this video is entitled HVAC or HVAC Week 3 Tutorial Air Conditioning System Part 2. So this is the tutorial session for Week 3 Air Conditioning System Part 2. So without further ado, let's go and visit our times page. Alright, so this is our times air conditioning and refrigeration engineering page. I would like you guys to go straight ahead to tutorials and answer, and then you will click on HVAC tutorial week. So when week 3 is on, I will unhide both HVAC tutorial week 3 and HVAC tutorial week 3 and answers for your guide for this tutorial session. So this is the my annotation PDF app that I'm going to use to discuss this question with you guys. So let's read the first question. Describe the air to water heat recovery system and show a schematic diagram of the system. So there is no answer in the question. So in this tutorial, if you still remember from our notes, that we have this recovery system in our lecture note. So here is what we call as air to water heat recovery. This is a pump. Okay, so this pump will bring in water. So as you can see there from the arrow, it moves from this and up and down and back again. So what it's doing is the pump is regulating temperature between return air and back to air conditioning system. I will put here RA and air and intake air, right? Intake air. Okay, usually these two devices are placed quite far from one another. Maybe between them is a few meters, maybe 10 meters, right? So the ducting for the return air and the ducting back to the air intake is quite far. So this pump is actually bringing water, and as water goes to the return air, it will bring in either hot air or cool air from this return air section into the air conditioning equipment. This method can save energy because we don't need extra, I put here, no need extra cooling or heating from the HVAC system itself. Right? So this is what we call as heat recovery. We take heat either from return air and back to the intake air. That means if you want to heat up a space in the winter, or if it's a cold air coming from the return air, that we can extract it and bring it to the air intake to cool down a space without using much of the cooling coil. Okay, that is for question 1. In question 2, consider an air conditioning system in a shopping mall requires cooling. The cooling coil, it's a cooling coil. Let me correct that. A cooling coil in the central part is followed by a chiller. Sketch a loop of cooling supply system of air handling unit by chiller and cooling tower. Right. So actually you can find this a lot in on the web. Okay. So let's see. on the next page talks about the sketch diagram. Now, the sketch diagram is here and there lah. And let's see, where should we start? We should start where the heat comes from. So the heat comes from the AHU. What? Oh, sorry. The AHU. What is AHU? Air handling unit. Usually it is situated end of the level. Let's say on level 4 of block B, right? i.e., for example, block C, level 4, and this is level 4. We have wing A, and then there is a bridge connector there, and then wing B. And usually sometimes the AHU is at the end, right at the end. Right, sometimes we have one AHU for each floor, sometimes you have two AHU. It depends on the space. If it's a big space, you need more than one AHU. So let's say the AHU is going to cool down a space. So the hot air coming from the tutorial classroom goes to the AHU. And then the hot water, let's take a red font. The hot water will move, suck out from the AHU. Oh, sorry. AHU to the chill water return. We just want to return the water. We call it chill water because to cool down a space, we need chill water to run through the loop. Right, from the pump, it will go to the evaporator. Right, and then evaporator, it goes to the rooms. That means from the space that you want to cool, and back to the AHU. Alright, now from the evaporator, it will go to a compressor, and from the compressor it goes to a condenser. Right, the condenser, if it's a split unit, is outside the room. So from condenser, it will go to the chill water to the pump, right, and then it will go into a cooling tower where the water is going to be cooled down, and then the cold water will return back to the condenser and compressor and back to the evaporator. So usually, right, from the floor, so this part is at the block floor level. We use refrigerant. Maybe the one that you are familiar with, R134A or R32, depends, right? But at the chill water section, at the cooling tower section, right, we will use water. Right, we will discuss this more as we go throughout our semester. Okay, the chill water system use water to cool down the space that comes from the floors or the AHU of each floor. Right, that is how it works. Okay, let's go for question 3. Recall the name of a system sketch in figure 1. Identify the name of its components shown from A to E. The system shown in figure 1 is applied in many places, including hotel rooms, offices, shopping center, and so on. However, its application brought out some issues. Explain the advantages and disadvantages of air, water, air conditioning system in figure 1. Okay, so this, let's go to scale this to the next page, is called a fan coil unit. It is usually situated in, if you go back to our all water system, we place it, this is U, right? And then this is the window, right? So fresh air go in and go out, and you have the fan, what's it called again? Fan coil unit, right? This fan coil unit will absorb heat and then will reject cold air, absorb heat and bring it to the cooling tower. I think it's cooling tower, so you can go back and check on the notes, right? Okay, so what is A is fan, where we suck in hot air from the room and then we purge in cold air towards the room. Or if you want to cool down, heat up the space, hot air will go up and then cool down or heat up the room. Number 2, a heating coil. So if this one is a heating coil. However, either you want to heat up a space so the hot water will move through this heating coil, right? And then the hot air will move from the room through the hot water and into the room. If you want to cool down a space, that means we use a blue color here to red color here. So the cold water will move through this, and the room is hot, maybe in the summer, so the hot air will go into here and out, and the place will become colder. Okay, so this is a fan so for both summer and winter. All right, so the drain pan will be C. Where is C? So this is the drain pan, and then we have a filter because we want to filter the dirt or dust that comes from the room. And the last one is damper. This one to open and close fully or partially, depends on the application. Now the drain pan. What is the use of a drain pan? Now, when we are in summer, we want to cool down the room, yeah. So usually cold water will move through the heating coil or cooling coil, depends on. So in summer it will become a cooling coil. So if you still remember in thermodynamics, the word dew point. What is dew point? Dew point means if the humidity with the relative reaches percent RH. Okay, let's clear that. Right? And the percent, water will start to condense here, and then it will drop into this drain pan, and either you manually bring it out, or of course you will have the system to take out the water from the drain pan. Okay, when we have this drain pan, we will reduce the moisture or water inside the fan coil unit, and this can be purged out because water and electrical components and metal, they're not good friends. So it will maybe in the future it will shortage, short and rust. Okay, we need to bring it out. Okay, what are the advantages? Can be used in places with constrained space, right? So this is again all water. Okay, economical, can be switched on when in use, and there's no need for central to be turned off because the radiator is just in the room. Okay, great flexibility to adapt to many building modules. Disadvantage, inefficient regarding to maintain indoor air quality. Filtration is not that effective because when you want the room to be cold, this window need to be shut, right? If you shut the window, the air circulation will just within the room and the room will become stale. odor, smelly cat. Right, the room becomes smelly. So this is the main disadvantage of a fan cold unit or air or water system. Last one, humidification is not practical because the room will become humid. And if it's become humid, it will absorb heat, latent heat, and you will become uncomfortable. Okay, last question. Sorry. Identify the component of central plant shown in figure 2. Record the parts and function they provide. 4B, recommend a system to be added to existing system to have variable flow rate. Demonstrate it on a figure. So let's see. Let's clear this up. Okay. So this is a multi unit or unit or multi-zone HVAC because it has a motor damper system. Okay. Now, what does the question ask? Identify central plant, record the name of parts. Okay. So there are a lot of parts here, so I just put here a few of them. Damper motor device control outside air to enter the air handling unit. Where do we have this? It's here. Damper motor. If you fully open, then all outdoor air will come in 100%. A partial close, so only a partial of outdoor air will come in. The same goes to exhaust air and the return air. So either you open the door or open the air, so you have fresh air come in, or you close this and the return air will just be from this zone. So okay, all right. B, filter material to embed in the entrance to purify the inner air from outside and or return air to control them from the indoor quality. Usually it is situated here. Okay. C, cooling coil. Of course, cooling coil is to cool down the room. A supply fan to blow air to provide ventilation inside the conditioned space because air will not move by itself. Air need to be blown, right? So this is the fan, move in and out, right? They need to suck up the air from the room or suck in the air from outside. And E, damper device to allow outside fresh air to come in if you open it using the multi-damper system. Okay. Now, recommend a system to be added to the existing system to have a variable flow rate. Now, this term variable flow rate, that means you need to have a variable air handling of I forgot VAV its name. So we haven't not covered this. We will cover this in the future in our lecture, so stay tuned. Okay, so that's all for our week 3 tutorial session. Alright, so thank you for listening to my video for week 3 air conditioning system part 2. So I'm looking forward to seeing you guys in lecture 4 or week 4 in the following week. Do remember to submit your attendance assignment, and if you have any further question, you can send your video link to me, or you can just ask me in time message or my email, my official email. Okay, I'm looking forward to seeing you guys later on. Bye.